Okay, hello everyone. From last 2-3 classes, we are discussing correlation coefficient, Karl Pearson's correlation coefficient, that is your R, equal to covariance of x, y divided by standard deviation of x into standard deviation of y. Also, we have been discussed scatter diagram, limits for correlation coefficient, that we found correlation coefficient will vary in between -1 to +1. Also, we have been discussed this theorem, that is a correlation coefficient is independent of change of origin and scale, which is very important theorem. By using this theorem, we are going to do numericals in this video. And in our last video, we have been discussed this one, uh, this theorem, and also we found a interesting result from this theorem, that two independent variables are uncorrelated. uh, that means if x and y are independent, then the covariance between x and y will be 0. So obviously its correlation coefficient will be 0, but converse is not true. That also we have been discussed in detail, and assumptions underlying Karl Pearson's correlation coefficient we have been already discussed. And in this video we are going to uh, discuss, or we are going to solve some numericals uh, by using Karl Pearson's correlation coefficient. Okay, or you can say that we are trying to find out correlation coefficient between two random variables by using Karl Pearson coefficient. Okay, so this is your first question, that calculate the coefficient of correlation or correlation coefficient between x and y from the following data. Here these are the two random variables x and y. How many data? 1 2 3 4 5 6 7 8. 8 data. X has 8 data, y also 8 data, and we want to find out the correlation coefficient between x and y. Okay, so before we have to start this, I suggest once again that note is very important for your exam point of view. So in our last videos, whatever uh, we have been discussed, we discussed from the book. We discussed from the book, but what you have to write, in which portion, in which line you have to write down your note, that also I have been suggested or given the instruction in those videos, and you have to follow. And here for this video you have to write down the question perfectly, then you have to write down your answer. Pause the video, write down the answer. Okay, so this is the data given in the question. That data is represented with the help of the table. You can see the correlation coefficient Rxy is nothing but covariance of xy divided by standard deviation of x into standard deviation of y. Here covariance of xy is nothing but 1 by n summation over xy minus mean of x into mean of y. Already we have been discussed in our previous video. Okay, you can check. Here we found covariance of xy is nothing but summation over xi into yi. This is one part, minus mean of x into mean of y. So same thing it has been written here. It has been written same thing, covariance of xy. This is your summation over x values into y values divided by total number minus x mean and y mean divided by sigma x and into sigma y. Here sigma x is nothing but summation over x square minus x mean square. Here x square means the values of x square and sum. That means in general it has been written in this way, that sigma x square, these things already we have been discussed. Okay, here you can see sigma x square is nothing but your x I square minus x mean square. Okay, here summation over x I square, that means all the x values square and you have to sum, then divided the number of values, right? So same thing it has been written over here, that summation over x square minus x mean square root over. Okay, you can see that Here sigma square equal to this much. So sigma x square equal to this much. So sigma x will be nothing but root over of this one. Likewise, sigma y will be root over of this one. So if I am going to consider sigma x into sigma y, that means root over of this into this. Same thing here it has been written. Okay. So 1 by n sum of x square, or you can say values of random variable x minus mean square of x, and for this one is your summation over all the values of y, random variable y square by total number of y, by mean of y square and whole root over. Okay, now here we have to find out xy, x mean, y mean, x square and y square. So for that, in this table we have been added another 3 columns. Here x and y, whatever given in the question, these are the values of x and these are the values of y, and here we added 3 columns for x square, y square and xy. So here x value is your 65, x square value is your 4225, likewise 67 4489, and here xy, that means 65 into 67 4355, that means all the values of x square has been written over here, all the values of y square, all the values of x and y. Okay, now we are going to calculate the total of x. Total of x is your 544 and y, total y is your 552, x square is your 37028, y square 38132, xy 37560. Okay, now we have to find out the x mean. X mean means I have to add all the values divided by number of values. Here 1 2 3 4 5 6 7 8 values, so addition of all the values, this is your 544 divided by n, that means 8, and we found mean of x equal to 68. Likewise, mean of y we can found 69. Here 552 by 8, 69, right? Now we are going to go for the coefficient of correlation coefficient, that is your rxy, that is your covariance of xy by sigma x into sigma y. So here covariance of xy equal to this much. So here summation over xy by n. Here you can see this data is represent summation over x of xy. So summation of xy by n is nothing but 8. Summation of xy is nothing but 37560. 37560 by 8, right? Okay. Then mean of x into mean of y. Mean of x is your 68 and into 69. 68 into 69. Very clear, okay? And root over of sum of x square minus mean of x square. So sum of x square here nothing but 37028. 37028 by total number is your 8 minus mean square. Here x mean is your 68. 68 square. Likewise here sum of y square nothing but 38132. 38132 by 8 minus y mean square. Y mean your 69. 69 square and whole root over. By solving this one, we can found the correlation coefficient will be 0.603. This is your answer, right? So here we found the correlation coefficient r x y rxy equal to 0.603. This is your correlation coefficient, right? So here we found that the correlation coefficient is your positive. That means from this data we can analyze that, or we can perceive that if x is going to be increase, y is going to be increase. That means averagely, if x will be increase, y will be increase. That means I suggest you that you do one thing, that you plot the x and y in your scatter diagram. You can found like this type of data. Okay, this type of data you can find, may not be, it will be exact. See here, x value is 65, then x value is 68. Just it is not uniformly increased, not uniformly decreased, all the y value as compared with x. But however, you are going to get this scattered data. That means averagely, when x will be increased, y will be increased. If x will be decreased, y will be decreased. So only for that, if it is so, or r is your positive, what we found, that is your 0.68, then this will be called as your positive uh, correlation coefficient, or you can say direct correlation coefficient. Okay, now the same question what we done now, the same question can be done either way. This is your shortcut method. That means here you can see that in if you are going to follow this procedure, this is your straightforward traditional procedure. If we are going to follow this procedure in your exam, then what we are going to face the problem, this calculation will be take much more time, right? So easier method, that we are going to be convert x and y by changing the origin and the scale. So in such a way that the u square v square uv calculation will be easy. You can see this example, you will be clarify upon that. Here we have x and y. I have been converted the x to u by x minus 68, v equal to y minus 69. So here this point, this point, this point has been considered as the mean of x and mean of y. Here 68 is your mean of x. Mean of x previously we found is your 68, and mean of y equal to 69. For this case, in this book, it has been taken that x has been transformed to u, another random variable, by considering x minus mean of x. That means here the rule in this book, they have been considered, the author has been considered that u equal to x minus x mean, and v is another random variable which transformed from y, from y by considering y minus y mean. Then if we are going to consider this transformation, what is going to be uh, happen, or in which way we are going to be perfect? See here, u and v are small numbers, we found small numbers, one digit number. So u square v square, it will be easy to calculate for us in our exam. Okay, or you can in your exam, and uv also it will be easy to calculate, and covariance it will be easy to calculate, and you are going to get the same answer. So first we have to discuss this one. And here one thing you are going to be think in your mind, or you can ask the question, that here in this book the author has been considered that u, a new random variable, is nothing but x minus x mean, and v is another random variable, y minus y mean. But always this uh, 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 rule we are going to be consider. That means always we are going to be subtract mean of the x, mean of the y. No, the answer is no, because previously we have been studied the theorem that if I will change this x and y, the given random variable, to another two random variable by any origin, by any scale, the correlation coefficient is unchanged. Any scale you have to use, or any origin you can shift, that correlation coefficient is not to be changed. That means what I'm going to say, that suppose if I'm consider u equal to x minus any number, suppose I'm going to consider suppose 10, okay, and v will be y minus 20, okay, or you can consider this is I changed the origin, okay, from 0 to 10, and here 0 to 20, and also you can consider u equal to x minus 30 by scale. Suppose you are going to change the scale, suppose 1 by 5 into 1 by 5, v you can consider 1 by 15, y minus uh, uh, y minus 20. So u and v can be written in by considering the change of origin and scale of x and y, right? So here there is no restriction that in what value you are going to be considered the origin and what scale factor you are going to be used. But here we have to remember one thing, that in such a way that one cleverness you have to use, that from the data you have to just check that what is the value that I have to choose, this one, then I can get u and v value will be single digit, right? Single digit. It will be it will be give us the single digit. Then the calculation will be easy for us. You got my point? So we have to transform x to u and y to v in such way that uv will be single digit. Try to just modify x and y in such a way that the uv will be single digit. If we got uv will be the single digit, then calculation will be made easy. So here, first of all, we are going to be discuss the alternative method or shortcut method, whatever given in the book. Then I am going to show you that if another value of this x minus something, y minus something, if I am going to take another value, also we are going to get same value. Here, this one I done for you in another number. Here we consider u equal to x minus 65. You can take anything. I told that x minus anything you have to take. No problem. But you just consider that after getting u and v, here we have to calculate u square, v square, uv. It will be somewhat easy for us, right? So here you can see that in the book it has been the author has been considered x minus 68, or the mean of the x, y minus y mean, okay. So we found u equal to the corresponding values are, see, 65 minus 68 minus 3, 66 minus 68 minus 2, 67 minus 68 minus 1, 67 minus 68 minus 1, 68 minus 68 will be equal to 0. Likewise, other data has been found. Likewise, here y value 67 minus 69 equal to minus 2, 68 minus 69 minus 1. Likewise, other data you can calculate. Now here we got u value are this one, v value are this one. So obviously u square values are here minus 3 square 9, minus 2 square 4, and all of the data we found. Likewise, v square data also we found. So right, whenever you are writing the note, carefully you have to write, okay. Pause the video and carefully write on the note. V square, likewise we got, and uv, that means this is your u and v value, minus 3 minus 2, minus 3 into minus 2 will be 6, minus 2 minus 1 2, like that uv data also we found. That means here initially xy where the data, and this xy has been transformed to another two random variables uv by considering origin here 68 and 69, okay. And here you can say the scale factor has been considered as 1. That means 1 has been multiplied with this much, x minus 68, y minus 69. But our the aim is that u will be small numbers, v will be small numbers, that u square, v square, u v we can easily calculate. Now u mean, here you can see u mean, you just add it, it will be 0. If you just add it, it will be 0. So u mean will be 0. You just add v. V mean means the sum of v by n. Here sum of v will be 0. The mean of v will be 0. You got my point? How it is very easy as compared with this one. Here we have to add all the things. Okay, it will be 5, 4, 4, then by 8, right? So adding again squaring, it will take time. But here it will be take lesser time as compared with first method. Okay, so uh, uh, v mean equal to 0, covariance of uv, because coefficient of correlation coefficient r is nothing but covariance by covariance of uv by standard deviation of u into standard deviation v of v. So here covariance of uv will be how much? 1 by n summation over uv minus mean of u and mean of v. Here you can see that here the covariance is nothing but summation over xy by n minus x mean y mean. So however, as the xy has been transformed to uv, so instead of xy it will be uv, and here u mean into v mean. So here u mean v mean value as 0, so this will be 0. So uv summation of uv, u into v summation is nothing but your 24 value, right? This is your 24 value. Value is your 24. You just put 24 by 8 will be 3. Likewise, sigma u square will be equal to 1 by n sum of u square minus u mean square. So u mean is 0. So u square, sum of u square is your 36, right? This is your 36 sum of u square. So 36 by 8 equal to 4.5, and here sigma v square equal to sum of v square by n minus mean of v square. So mean of v is your 0, right? And sum of v equal to 44. So here we have to write 44 by 8, that is your 5.5. So correlation coefficient uv will be how much? Covariance of uv by standard deviation, that means root over of this one into standard deviation of v, sigma v. So sigma v square equal to this much, so root over of 5.5. So root over of 4.5 into 5.5, we are going to get 0.063 is exactly this one. So here we found that if we are going to be convert xy to another two random variables by considering different origin, different point x except origin, and by considering scale factor, also there is no change, it is unchanged. Also this is already we have been proved in the theorem. Now the same we are going to be solved by considering here this table, here I consider that x minus 65. Here we have been we can see that x minus x bar, y minus y bar, but here I consider x minus 65, means here I consider the first number and first number. You can consider anything, I told anything you can consider. So you just check this one how I solved it. See, method is same, but here whenever if we are going to calculate everything, also we are going to get the same answer, 3 by root over of 4.5 and root over of 5.5. This one 3 by 4.5 root over of 4.5 and 5.5. Let's see. Okay, let's discuss this one detail. See, I suggest to all of you that also you have to write down this answer also. Pause the video and write down this answer. Okay, but you have to follow this one because it was somewhat easy calculation. I can say easy calculation. Here you can see. Okay, see, u equal to x minus 65 I have been considered. That means x has been transformed to another random variable u as x minus 65. What we can get? See, 65 minus 65 0, 66 minus 65 1, 66 7 minus 65 equal to 2, and likewise we can get all the values we can get, right? So sum of u, we can get 24 here. Likewise y minus 65 67, so 67 minus 67 0, 68 minus 67 1, 65 minus 67 minus 2, and all the values likewise we can get. The sum of v will be 16. This is your 16 value. You just add all, you can get 16 1 6. Okay, then we are going to go for the u square. U square means these are the u values and corresponding u square values. So 0 square 0, 1 square 1, 2 square 4, 2 square 4, 3 square 9, like that. And sum of u square equal to 108. Likewise v square we have to consider, and sum of v square equal to 76. uv, that means here these are the values are u and these are the values are v. So uv means here you can see 0 into 0 0, 1 into 1 1, 2 into minus 4 minus 4, 2 into 1 2, uh, 3 into 5, this is 15. Okay, likewise other values can be calculated. So sum of, this is the sum of uv, we can get here 72, right? Now we are going to go for the covariance, correlation coefficient. Correlation coefficient R, we know that covariance of uv by standard deviation of u into standard deviation of v. So covariance of uv, for the covariance of uv we need sum of uv minus u mean v mean. Okay, so first u mean, here u mean will be sum of u by total numbers of values, uh, will be 8. So here u, we found sum of u 24 by 8 equal to 3. Here sum of v by n, that means 16 by 8 equal to 2. So u mean and v mean we found 3 and 2, right? So here by mistake I written small u, but it is considered as a large capital. Okay, now we are going to go for the sigma u square. So sigma u square is nothing but sum of u square by 8 minus mean u square. Mean u we found 3, so mean u square equal to 9. Sum of u square we found here 108. So 108 by 8 minus 9 we can found 4.5. Sigma v square, you can found v mean square, here sum of v square minus v mean square. So here v mean is equal to 2, square is 4, and sum of v square equal to 76 by 8 is your 5.5. And covariance is nothing but sum of uv minus u mean into v mean. So sum of uv, u into v, sum of u into v we found 72. 72 by 8 equal to 9. Here 3 into 6, sorry, 3 into 2 6, so 9 minus 6 equal to 3. So covariance of uv we found 3, and here sigma u we can found root over of 4.5, sigma v root over of 5.5. So r equal to covariance of uv by sigma u into sigma v, that is nothing but here we got 3 by root over this one, root over this one. You can get 0. Here 0.063 0. Sorry, 0.603 0.603. So here I suggest that one thing you have to write down in 3 way in your note. Okay, this way you have to write, and this way you have to also write, and this also you have to write in your note for your practice. If you are going to write this one, so you will be more practice. So if you are going to be write this one in your note, then your practice will be more, right? And as I told that u and v can be taken anything, can be taken anything, x plus or minus any number into or divided by this value, right? That means scale factor you can take anything and origin you can take anything, but you have to keep in mind that I have to or we have to transform x to u, y to v in such a way that our calculation is going to be reduced or is going to be easy. You can say calculation will be easy and it will be save our time in our exam, right? So here we have to stop our uh, today's discussion, and in our next class we are going to solve another few numericals based on your Karl Pearson's correlation coefficient between two random variables. Okay, so thank you so much for watching this video. Thank you.